Okay, so the first to-do I see here is a refactor right here in the constructor. So we're in the constructor for news view model, bad async await practices. And I'm getting a squiggly line here because I'm calling this refresh method down here, which is an async task method, but I'm not awaiting it. And like we learned earlier in this course, we always want to await every task because non-awaited tasks hide exceptions. So what do we do here? Well, you might think, well, let's just slap on async, let's slap on await. And no, that doesn't work. We're always going to get yelled at for this because async await is actually invalid in C# constructors. And if you think about it, it makes a lot of sense because async await is meant for long-running tasks that we want to return to later once they're finished. But the purpose of a constructor is just to initialize an object, assign it at a location in memory, and maybe we pre-assign some values to our properties or something simple like that. But constructors are not meant for long-running tasks, which is why they don't support async await and likely never will. So let's get rid of async await here. And we're back to our yellow squiggle. Well, one thing we could do here is I could create a method down here called refresh. And in this method, I can await refresh, and then I can call our new refresh method from the constructor. And there we go. We got rid of our yellow squiggle. We are awaiting this task refresh so that if an exception does get thrown in our refresh method, it'll be rethrown to us, the developer. We can catch it. We can handle it gracefully. But what's strange about this is I've just created an async void method. And I can feel you cringing from the other side of the screen because what are we taught as C# developers? Don't use async void. Async void is dangerous and it should only be used for event handlers. And while that's not bad advice, you won't get in trouble following that advice. The problem I have is when folks tell you that, they never tell you why. So why is this dangerous? Well, let's say that this method throws an exception. So let's just force it in here like this. And now we know that this refresh method, this async void refresh, will always throw a new exception. Well, what do we do? No problem, right? We can just wrap our code in a try catch block here. And we can handle the exception. Happy days. But let's think about what happens with thread 1 under the hood now that we know how C# compiler generates all this async await code for us. Let's say thread 1 initializes news view model. So thread 1 enters the constructor. We assign Hacker News API service. We enter this try catch block, and then thread 1 hits the refresh method where it jumps down to here and it enters this block of code. But the first thing it sees is the await keyword. And we know now that when the calling thread hits an await keyword, it returns, assuming that task hasn't completed yet. If the task is completed, then it'll just grab the result and continue on. But in this case, we know that the refresh method is calling public APIs to update our top story collection. So in this case, it hasn't completed yet, and it never will have been completed. So every time thread 1 enters this async void refresh method, it hits this await keyword, and it returns. And it returns back to where it entered the method. But since we're not awaiting the method because, well, we can't, it's async void, you cannot await an async void method. So thread 1 returns and it just continues on. So thread 1 continues. And let's say we have some extra steps down here where thread 1 then continues on to maybe clear the list and add some extra stories to our top story collection. There we go. And now thread 1 is working on our top story collection. Meanwhile, a background thread, let's say thread 2, is walking through the refresh method where it also modifies top story collection. And what we've just done is we've introduced a race condition into our code, meaning I have thread 1 interacting with top story collection here, And I have a background thread, in our example, thread 2, interacting with top story collection down here. So now we have two competing threads, both overwriting each other, where they're both clearing our top story collection, they're adding new stories to the top story collection. And this is bad. This is how we accidentally introduce bugs into our code, because 99 times out of 100, this code works fine because thread 1 will get here faster than, say, the background thread or thread 2 will get here. But what if get top stories is cached? It's just a get API that could absolutely be cached on edge server. And these results could come back very, very quick. And we might run into that scenario where thread 1 is now clearing the top stories that thread 2, our background thread, have fetched and added to the collection. This is one way or one reason why async void is dangerous. Now, let's assume that the background thread, thread 2, successfully completes the refresh method. So now thread 1's completed. It's cleared our top story collection. It's added a new story and it's exited the constructor. It's off doing something else. But meanwhile, thread 2 just finished. So what happens down here is this refresh method is still running. And now we know that this is going to throw an exception. And you might think at first, hey, no problem, because we're calling refresh from our try catch block. But remember, when thread 1 hits this await keyword, it returns and it continues executing because we cannot await an async void method. So what's going to happen when the code hits this line right here? Our app's going to crash. There's nothing there to catch this exception, and boom, our app crashes and there's nothing we can do about it. The first reason why async void is dangerous is we can easily introduce race conditions. The second reason is that it's almost impossible to catch exceptions from an async void method. So if we call an async void method, you could try and wrap it in a try catch block, and hopefully that exception gets thrown before the await keyword is hit, because then this would work, but it's not reliable and we can't depend on that. So for all intents and purposes, we should never expect to be able to catch an exception from an async void method. So that's the second reason why they're dangerous. Now, in this simple example, the async void method's right here. It's very much in our face. When I click on refresh, the method gets highlighted down here. Heck, if I say go to declaration, it's right there. We can see it, and maybe this is idiot-proof enough for us. We wrote the code, we can see it right here. But let's say refresh isn't right here. Maybe refresh exists in a different class, in a different file. If we pretend like we can't see it right here, but we're still using it in our constructor, well, when I use IntelliSense to write my code, I'm going to call the refresh method, and IntelliSense is going to show me that this returns void. Now, as C# developers, it's absolutely valid for us to see that IntelliSense tells us a method returns void, and it's absolutely valid for us to assume that this method will finish running before it moves on to the next line of code, meaning there's no reason for me to expect this line of code to run before refresh completes. Now, it would be great if IntelliSense one day would say that this is a private async void method and maybe give us a little warning that, hey, maybe you don't know it, but you're actually accessing an async void method, and there's no guarantee that that method will finish before you run, and there's no guarantee that a try catch block will catch an exception from it. But as senior C# developers, it's absolutely valid for us to trust the IntelliSense. And this is really where that advice comes in to avoid async void. Because again, if this is in a different class, I have no idea. And now I have a race condition in my code and a possible crash when this refresh method finishes, or rather a guaranteed crash in our instance because I added a hard coded exception here. So we do want to avoid async void, but at the same time, this is a valid implementation of async void. So what do we do, right? Because we want to avoid it. So let's get rid of this. Let's blow this away. And let's get rid of this part, and there we go. Put in that cancellation token again. So I get rid of the red squiggle and exchange it for a yellow squiggle. Well, we're basically back to the original code, back to the original problem where we're calling an async task method from the constructor. We know we cannot use async await because constructors don't support that. And we know that we should avoid async void. Well, what do? This is actually where that async await best practices library that I mentioned a minute ago comes in. Because I've created a safe fire and forget extension method that allows you to call a task, in this case, this refresh async task method. And when you call safe fire and forget, it'll allow that task to continue running in the background, again, assuming it hasn't already completed. Meanwhile, safe fire and forget will include all of the proper guardrails to ensure that we still await the task under the hood and that we can catch the exception if we want. So let's actually dig into this code for just a second, just to show you what's going on under the hood, because it's actually using async void under the hood, but it's using async void in a safe way to ensure that we can still catch the exception when it's thrown. There we go. So by wrapping that task that we're fire and forgetting inside of a try catch block, this ensures that if it does throw an exception, we can handle it. And the way the extension method works, we can tell it how we want to handle that exception. So maybe we just want to say trace.writeLine for this example. Maybe you want to pass this into your crash reporting tool, but however you want to do it, we can handle it right here. And if we know specifically what exceptions we're looking for, like if I'm looking for a, let's see, HTTP exception, then now we can actually access that HTTP exception. Whoop, what's going on here? There we go. So now, if we wanted to be very specific, we could say trace.writeLine, and we could specifically look at, say, the inner exception of this HTTP exception, or the HTTP request error inside of this HTTP request exception. So highly recommend Safe Fire and Forget. I know I'm biased because I am the author of Async Await Best Practices, but just to show you, it is being used by lots and lots of developers around the world. It's actually being used by folks at Mozilla, which is really surprising to me. And I've just released .NET 9 support, and it looks like, wow, we're at 2.6 million downloads. So again, I know I'm biased, but with 2.6 million downloads and companies all around the world using it, hopefully other folks agree with me that it's absolutely worth it. So with Safe Fire and Forget, it's still going to allow the calling thread to continue running. So refresh is still going to be called by thread 1 in our example. Thread 1 is going to enter in the refresh method, and then eventually it hits this await keyword and it returns. And thread 1 is still going to continue on here. So let's actually get rid of this code because we don't want thread 1 to be accidentally introducing any sorts of race conditions for us. But the nice thing with Safe Fire and Forget is by adding this extension method, it's very, very obvious that you want to execute this task on a background thread, and you don't want to wait for it to finish before moving out of the next line. So in this example, thread 1 will continue onto this line of code while refresh is still running. Now let's pause here before we move on to the next section where we'll cover cancellation token, configure await, .wait, and .result.